Sir,
Yes.
sir, I have doubt in मतलब vectors का एक concept.
Who is this?
Sir, Nikhil.
No, Nikhil. After the class, once it's done, we will discuss. Okay. Today. So everyone start revising oscillations. I think we have done displacement at mean, displacement at extreme, velocity at mean, and velocity at extreme. I think velocity at mean, we don't know the value, but we know it is maximum, correct? So tell me the formula that we already know, check from this chapter. Tell me. F is equal to
minus
kx.
kx.
K equal to m omega square. Correct?
Yes, sir.
Now the next thing we did was correct. Now at mean, anything else we have done? Let me know. Check. Anything else we have done? No?
We
Okay,
did
fine.
here only.
We'll do till here. Okay, so start revising this much. Then I'll ask you and then we'll proceed today.
Okay.
Okay, now listen to me. Look here. We have to find time period of oscillation. What is the general formula for time period? Anyone? Over here, there, here, anytime. What is the general formula for the formula? 2 pi by omega.
Yes, sir.
Now I am writing one formula. Listen to this. I will tell you that the formula for time period of oscillation is equal to can anyone prove it? How? You already know from which formula you get this answer. Think about it. Can anyone prove it? How? I am telling you that the formula for time period is 2 pi root of m by k.
Sir, sir, we can do it with that
angular
spring,
frequency.
yeah,
K
spring
is equal
constant
to
and
into
angular
omega square.
frequency is equal
And-
to 2 pi by t.
Sir,
Hmm.
using omega का वो result.
Yes, sir. We'll take omega down and t above. So
You
it
are
will
telling
be-
me, look at this. Look at this. We have to prove this formula. So you are telling me we know omega is equal to 2 pi by t, correct? Therefore, you are saying t is equal to 2 pi by omega. Now, how did this answer come?
Sir, k equal to m into omega square.
Yes. So start, derive it, and all of you, I'll also do it on the screen. For people who have got it, very good, do it. And for people who have not got it, try to do it. And if not, I will do it on the screen. But nevertheless, this is going to be your formula for time period of oscillation. Brilliant formula. Why I'm telling time period of oscillation? Please look at the screen. Why I'm telling time period of oscillation? Because this formula for time period can be used only in oscillation chapter. I cannot use this formula for time period in any other chapter. But can I can use this formula for time period in any chapter? This is called general formula. This is called time period of oscillation. Only when the body is oscillating, I can use this formula. For start.
Sir, done.
Sir, it would be k by m, right?
No.
Acha, ha, okay.
Yes. Now, sir, M will go up now. Yes.
I have done the derivation on the screen. Did you understand what is it? How is it? Brilliant, brilliant, masterpiece. Correct, masterpiece. Yes, masterpiece.
Yes, sir.
Got it, all of you? Okay. So if I ask you, what is the time period of oscillation? You will tell me omega is equal to 2 pi by t, t is equal to 2 pi by omega, t is equal to 1 by f, all are correct. But if I ask you specifically what is time period of oscillation, then you will tell me this answer, because this answer will satisfy most of the roots. T is equal to 2 pi root of m by k, and the SI unit of it will be second itself, because ultimately it is time. Ultimately it is time. Therefore, can I say SI unit will be second itself? Okay. Now my next topic is acceleration of oscillation. And after that, the topic is velocity of oscillation. Don't write. And after that, the topic is displacement of oscillation. I want to give you the direct result. Should I give you the direct result? Or you want to derive it with me? Derivation is actually for 12th standard. For you, the direct results are fine. Tell me, what approach do you want to follow?
Sir, derive.
Sir, derivation.
I should derive, all of you.
Yes, sir.
Then told me,
Yes,
sir,
it's
it's very
fine.
tough. Oh my God. Don't tell me, sir, it's very tough. I didn't understand the derivation. Just give me the final formula. Should I derive it for you? How did the formula came?
Yes, sir.
Everyone, please tell me.
Also.
At times it gets confusing.
I should just give the formula. All of you answer. This is a class of 26 people, right? 26 people answer. Yes, no.
Yes, sir.
Sir, derivation.
Private, sir.
Derivation.
Derivation.
Yes, sir. Okay, fine.
Sir,
You asked for it. You asked for it. You asked for it. Okay.
sir, give one derivation. We'll see after that.
No, it is a package. It is a package. Like if you ask for Nyraj sir, you will get the whole package. Means you will get physics also and you will get free shairi also. You have not heard my shairi, but
No,
when you hear
no,
my
sir.
shairi.
Sir, now we want to hear.
What do you want to hear?
Shairi or shairi. We have not got the second part of the deal yet.
You have
Yes,
never heard my shairis?
No, not even one.
No, no,
What,
sir.
sir?
Okay, at the end of the class, remind me, I'll tell you one shairi. Many shairis are there, I'll tell you one shairi. But in that,
Okay.
we need live audience to do wawa, irshad, and throw money. And
Yes,
all.
sir, sir. We will do that.
Sir,
Sir, we won't be able to do the latter,
Sir,
but
we'll
other
throw
things we can.
bitcoins.
I will throw bitcoins.
First, tell me that you would be able to understand, and then we'll proceed. Okay.
Okay.
Okay, sir.
So first we'll do this and then shairi, correct? Okay, good. Acceleration of oscillation. Now I will give you a package. Okay, now how I give my package? Okay. So listen to this. Everyone, look at me. We have to find, especially if you're doing MHT-CET and boards exam, this will help you. If you're doing JEE, this derivation will not help you as a derivation, but it will let you know from where did the formula come. Otherwise, I can directly tell you the formula. What will happen is if you by heart one formula, 2-3 days you might remember, after that you might forget. But if you have derived it, in the exam you can derive it again. Correct? If you derive it, you can derive it again. So listen to this. I need to derive. We'll have to go like a mehfil today. Okay, since it's a shairi evening, we'll go with a mehfil. Anyone else does shairi in the class? Tell me. Anyone else shairi?
No, sir.
No?
No, sir.
Correct? All right. Okay. Okay. We will go with 1, 2, 3. Then we'll do one more thing. Then I'll give you free financial advice also. Have you heard about financial advice?
Yes.
Yes, sir.
Okay. That also. Have you heard from me financial advice?
No,
No,
sir.
sir.
Only today.
That also.
Sir,
That
but I heard your TED talk once.
Acha, you heard my TED talk. Okay. Then I'll give you my other talks also. You hear for financial advice. Okay. Now, we have to find 3 things for oscillation. How many things? 3 things you have to find for oscillation. This is purely for oscillation. That means the formula that we get can be used for oscillation only. One is acceleration, one is velocity, and one is displacement. One is acceleration, one is velocity, and one is displacement. Clear? So at the end of it, I will get one formula for acceleration, one formula for velocity, and one formula for displacement. Now, these formula that we get are for oscillation only, just like the previous one which we got for time. Which did we get for time? T is equal to 2 pi square root of m by k. Okay. Now listen to this. So let's start. To find acceleration, I will use 2 formulae for force. To find acceleration, I will use 2 formulae for force. To find velocity, I will use 2 formulae for acceleration. And to find displacement, I will use 2 formulae for velocity. Okay. Now don't back out. Now don't tell we don't want derivation. Now listen to the derivation. Let us start. Tell me, what are the 3 things you need to find out? Repeat.
As
Repeat.
acceleration,
You need to
Acceleration,
find acceleration,
velocity, and displacement.
velocity, and displacement. Clear? Now to find acceleration, what do we use?
2 forces.
2 formulae for force.
Two
Very good.
formula of forces.
To find velocity, what do we use?
Two formula of acceleration.
Acceleration.
Two formulae for acceleration. And to find displacement, what do we use?
Two formula
Velocity.
Formulae for velocity.
Two formulae for velocity. Correct? Now, let me go a little bit deeper. To find the value for acceleration, I will use two formulae for force. One will be general formula, one will be specific formula. That means the formula that you have learned in this chapter. Similarly, to find velocity, we will use two formulae for acceleration. One general formula, one specific formula. And to find displacement, again we'll use two formula. One is general formula, one is specific formula. I went one level higher. Okay, now let us start again. Shall I start? Okay, tell me, how do I start?
Acceleration, velocity, and displacement.
Acceleration, velocity, and displacement.
Two formulas for force, acceleration, and velocity respectively.
One general, one specific, one general, one specific, one general, one specific. We have not started the derivation, but I'm telling you the skeleton. I'm telling you the skeleton so that when I do the derivation, you will not log off. Okay, now listen. Two formulae for force, one general, one specific. Tell me one general formula for force that you know every chapter.
Mass into acceleration.
MA.
Mass into acceleration.
So derivation started already, we don't know. Now tell me the specific formula for force that you have learned in this
Minus
chapter.
kx.
Minus kx. Excellent. Therefore, can I say after doing something, some jugaad, I will get answer for acceleration. Now to find two formula for velocity, one is general and one is specific formula for acceleration. General formula for acceleration, tell me, do you know this?
Yes, differentiation. No?
Yes, sir.
We did it in the first class itself. Acceleration is equal to dv by dt. And the specific formula for acceleration, I will get from the previous derivation. Okay, 1 minute.
Yes, sir.
Equals to f upon ma.
Can you hear and see me?
Yes.
So one general formula for acceleration and one specific formula. One specific formula we can get from the previous derivation itself. Now to find the value of displacement, again, I will use two formulae for velocity. One general formula for velocity. Do you know this?
Yes.
Yes, sir.
And tell me the specific formula for velocity that you know.
We'll get it from that.
We will get it from our previous derivation. Excellent. Over. Now we have to just derive. Okay. So let us do one final recap. Okay. Everyone listen. How many things we need to find? We need to find three things. One is acceleration, one is velocity, and one is displacement. Therefore, first I have to find acceleration of oscillation, velocity of oscillation, displacement of oscillation. Now to find acceleration, okay, acceleration of oscillation, I will use two formulae for force, one general and one specific. To find velocity, I will use two formulae for acceleration, one general and one specific. And to find displacement, I will use two formulae for velocity, one general and one specific. Start. What is the general formula for force?
Mass into
Mass
acceleration.
into
Mass
acceleration.
into acceleration. What is the specific formula for force?
Minus k.
Minus kx.
Kx.
Minus kx. What is the general formula for acceleration?
dv by dt.
Derivative.
dv by dt. What is specific formula for acceleration? We will
We'll
get
get
from here. Now, what is the general formula for velocity?
dx by dt.
Dx upon dt.
And the specific formula for velocity, I will get it from here. Now we just have to derive one by one. So make a note of the general syntax. That will help you in the derivation. Start, make a note. Okay, shall we start now?
Yes, sir.
So now let me go into the first box. Let me go into the first box. Tell me what I need to find in that first box finally.
Acceleration.
Acceleration. So how do I start? Two formulae for force. Tell me.
Force, yes. Force
F is
equals
equal to
mx minus
correct these two formulae for force.
yes, sir.
Therefore, can I say since both are force, can I say ma is equal to minus kx?
Yes,
Yes,
sir.
sir.
Can you tell me what is k by m? Looking at some formula.
Omega square.
Omega
Yes.
square. Yes.
Omega square. Check. It is omega square.
Yes, yes. Omega square, sir.
Therefore, acceleration is over first derivation.
Yeah, easy, sir.
Therefore, from because it just started. Now
No.
velocity will come. But it's okay. It's easy. It's easy. Nothing is difficult, right? It's always easy. Okay. Now, acceleration is minus omega square x. Therefore, today you learn two new things. Today you learn, if I ask you what is time period of oscillation, you will tell me it is 2 pi root of m by k, time period of oscillation. And if I ask you what is the acceleration of oscillation, you will tell me it is minus omega square x. Easy?
Yes, sir.
Okay. Now tell me, shall we start with the next derivation?
Yes, sir.
Yes.
Okay. Now tell me, in this derivation, what do I want? In this derivation, I want velocity, correct? And I have to start with two formulae for acceleration, one general,
Yes.
dv by dt, and one specific. Now, can I use this formula now?
Yes, sir.
So I
Yes,
used one
sir.
general formula, one specific formula. Now the actual derivation comes. Now concentrate. Look at me. Look at me. Can I say dv by dt? Therefore, acceleration is equal to dv by dx into dx by dt. Can I write it like this?
Yes, sir.
What did I do? I multiplied and divided by dx. Therefore, it is dv by dx into dx by dt. Therefore, acceleration is equal to, please look at the screen, then you do it, look at the screen now. Can I say
Into velocity. Yes, sir.
what did I do? I wrote, see here, first what did I do? I multiplied and divided by dx. Can I say that if I multiply and divide by some number, the value remains the same? I'm not altering the value if I multiply and divide by the same number. So when I multiply and divide by the same number or same term, dv by dx I write as it is. Can I say dx by dt can be written as velocity? Because velocity is nothing but dx by dt. Therefore, can I say my value of acceleration is v into dv by dx?
Yes, sir.
And I also know that acceleration is equal to minus omega square x. Now I will take this as my equation 1 and this as my equation 2. Now can I equate? Now can I
Yes,
equate?
sir.
So if I equate, what will I get? V into dv by dx is equal to minus omega square x. Minus omega square x, correct? What do I want? What do I want? I want V. Now listen to me carefully. I can write V dV is equal to minus omega square x dx. I kept V terms on one side and x terms on the other side. I kept V terms on one side and x terms on the other side. Now continue.
So V is equal to minus omega square x dx upon dv.
Yes, but still I have dx, still I have dv. Now tell me, I think you're too young to know this, but I think you will know this. What is the best way to remove differentiation?
Integrate.
Integration.
The best way to remove differentiation is integration. The best way to remove differentiation is integration. So what I will do is I will integrate both sides. I will integrate both sides. So I will write integration of v dv is equal to integration of minus omega square x dx. Till you understood, everyone?
Yes,
Now,
sir.
what is integration of v dv? Means what is integration of x dx? We have done it together. Can I say it is
Yes,
Yes,
x
sir.
sir.
power n plus 1 divided by n
Yes,
plus
yes.
1 plus c is equal to, can I say this is integration with respect to x? Therefore, any term which does not have x can be taken outside as constant. Therefore, it will become minus omega square integration of x dx.
Yes.
Or can I say v square by 2 is equal to minus omega square
X square by 2.
X square by 2. X square by 2. 2 to get constant.
when we complete our integration, you know that you have to put plus integration constant.
Yes, sir.
Now, if it was mathematics, my answer is done. I got my answer. If it was maths, I could leave my answer like this. But in physics, I cannot leave any constant. I have to find the value of the constant also. I'll tell you why. In maths, I can say this is the answer over. Full marks in maths, 100. Very good scholar. Now, if I tell you, you have to launch the rocket with the velocity of 30 plus c, where c is any constant of your choice, will the rocket launch? I have to give exact value of launching of rocket. Or imagine in biology, if a doctor says you have viral fever plus c, where c is any disease of your choice, will it work? No. Can I say you have to be very precise in your answer? So can I say this answer is not precise? This answer has a constant. Now what I will do is, listen to me clearly. Now what I do on the next page is only to find the value for c. I will find the value for c and put it back in this equation. Are you with me? What I will do now,
Yes.
or what I am going to do now, is just to find the value for c. Once I find the value for c, I will put it back in this equation and I will continue my derivation. Okay. So what I will do is, where did I stop? I stopped at v square by 2 is equal to minus omega square. I am taking this step, last one. Which step? This one. Correct? Now to find c, tell me, can I consider mean position or can I consider extreme position? Last class I told you which position is better for us. Extreme position is better for us. Tell me why.
Sir, that velocity is 0.
No, velocity is 0.
I will consider extreme position because at extreme position, I know the value of x also, and I know the value for v also, which in mean position I don't know.
Correct.
Position I don't know. Correct? Now, put these values in this equation and tell me what is the value for c. Start. Therefore, I'll get 0 square by 2 is equal to minus omega square a square by 2 plus c. Or I will get 0 square by 2 is 0 is equal to minus omega square a square by 2 plus c. Therefore, c is equal to omega square a square by 2. Everyone getting this answer? Now,
Yes.
this answer of c, I have to put it back in this equation and continue my derivation. Therefore, whatever I did on this page was just to find the value for c.
Constant.
So make a note. Make a note.
Sir, can you please explain again that how did you find C?
How did I find c? Correct? How did I find the constant?
Yes.
Yeah, see, this is my equation. Now I considered extreme position. Now at extreme position, I know from my last class that displacement is always plus or minus a and velocity is 0. I considered extreme position. At extreme position, displacement is always plus or minus a and velocity is 0. Therefore, if I put x is equal to plus or minus a, and if I put velocity equal to 0, then I will get the answer for C, which is omega square a square by 2, which is omega square a square by 2. Correct?
Yes.
तो सर velocity 0 होगा.
What?
Velocity will be 0.
Only at extreme position. Remember, I am doing this just to get the value for C, and I got the value of C. Again, I'll continue. Velocity won't be 0. At extreme position, velocity 0. That is what I have considered.
Jigar, were you there for last lecture? Jigar. Sir, I think Jigar was absent for the last lecture.
Yes, sir.
Achha, that's right. Now, can I put the value of C back?
Yes, sir.
Therefore, listen to this. I will get V square by 2 is equal to minus omega square x square by 2. Correct, here? V square
Yes.
by 2 is equal to minus omega square x square by 2 plus constant. What is the constant?
Yes.
Okay. Now,
Answer out. Yes.
understood?
Sir, yes.
Understood?
Yes, sir.
This is my answer.
Wow.
So, for people who do want the derivation, this is the derivation that we did from the beginning. If you, yeah, this is the derivation from the beginning.
Sir, wait. We'll note it down.
Shall we do it once more on a new page?
Yes.
I'll explain on this. Okay, I'll explain on this only then very quickly. See here. To find velocity, I will need two formulae for acceleration. To find velocity, I will need two formulae for acceleration. So I took one general formula and one specific formula. Specific formula, keep it as it is. In general formula, what do? I multiply and divide by dx. I multiply and divide by dx. So dx by dt will become v. Therefore, acceleration will become v into dv by dx. Another formula for acceleration is minus omega square x as it is. Now I will equate this and this. Have you finished noting down the first page?
Sir, 1 minute.
Okay, make a note. Take 30 seconds. Make a note.
Sir, done. Sir, done.
Now, can I say I can equate these two? Therefore, can I say v is equal to dv by, so v into dv by dx is equal to minus omega square x. So what I will do is I'll keep v terms on one side and I'll keep x terms on other side. Now, since v has a differentiation sign, the best way to remove differentiation is by integration. So I'll integrate both, and integration of v dv is v square by 2, and integration of minus omega square x dx is omega square constant, integration of x dx is x square by 2 plus c. This is the complete information on this page. Make a note.
Sir, can you show the working for constant?
First, finish this slide, all of you.
Yes, sir.
Now, the
Done.
working for constant is, I will consider extreme position. I will consider extreme position. At extreme position, I know that x is equal to plus or minus a. And I also know that velocity is equal to 0. Therefore, putting these two values in this equation, I get the value for c as omega square a square by 2. Can I go to the next slide?
Yes, sir.
Now by putting c is equal to omega square a square by 2, I get the final answer for my velocity, which is plus or minus omega root of a square minus x square. Okay, now look at this. Look at this trick. Now my third derivation is to find displacement of oscillation. My third derivation is to find displacement of oscillation. Tell me, how do I start? I start with two formulae for velocity, one general and one specific. Correct? Now look at this thing. Now, many times students, what they do in the exam is they confuse. They put a into omega square minus x square or x into a square minus omega square. The best way to remember this is wax. Check. That means first W should come, A should come, and then X should come. No. These two formula there. These two formula there. Now listen to this. Directly, I will equate. This is the easiest derivation. Directly, I will equate. Tell me, what will I get?
Yes.
Correct? Directly, I can equate. Now, what I do is I take X terms on one side.
So now
Correct?
integration. Yes.
Yes. Now integration. Plus or minus, I'm ignoring. Understood this page? It's direct. So what did I do? I took V is equal to dx by dt and V is equal to plus or minus omega root of a square minus x square. Therefore, dx by dt is equal to this. Therefore, dx by this is equal to omega into dt. Now integrate both sides. Now, luckily for you that you will learn in 12th standard also. Please look at the screen. Let me write this step again. Okay. Now listen. Luckily for you, integration of 1 by root of a square minus x square dx, there is a direct formula, sine inverse x by a. You will learn it in 12th standard also. There is a direct formula, means integration of this is directly this, sine inverse x by a. Derivation also is there in your 12th. And if do you have a logbook with you? Logbook. In logbook, last page also this formula is direct. Is equal to omega integration dt. Correct? Omega integration dt. Listen to me carefully now. Therefore, sine inverse x by a is equal to omega. Look at the screen. Integration and differentiation will cancel. I will get omega t plus some constant phi. Last time I used c, this time I will use phi. Or can I say x by a is equal to or what is x equal to?
Yes, sir.
Sir, second step, what do you do?
Integration of this is a direct formula, sine inverse x by a.
Yes.
Integration and differentiation cancels. I will be left with omega t. Since integration is over, I have to add some integration constant. Sine inverse, if I take on the other side, I will get sine. A, if I take it on the other side, it will become a. Therefore, my final answer, this answer is not complete. Can anyone tell me why?
Constant value.
There's a constant.
There is a constant value, which I will do it in my next derivation to find the constant. But for now, the general formula for displacement is a sine omega t plus phi. With that, we completed all three derivations.
Okay, sir.
Now my question is, can you start? Listen to this. Okay, first finish this. First finish this. Done?
Yes.
Now my question is, look at the syntax now, what we started, from where we started, and tell me what did our final answer come as? Acceleration became minus omega square x. Velocity became plus or minus omega root of a square minus x square. And my displacement became a sine omega t plus phi. Can I say this completes my three main equations: acceleration, velocity, and displacement. Now, can you start from here again and come till here? 5 minutes. Can you start without saying all three derivations back to back? The clue is over here. This page is your clue. Just by using this page, try to get it started.
So for the last one, we don't have to find the phi.
That I'll come now. That will come now. But the general formula for displacement is this. Then I'll tell you how to find phi. Okay.
Okay.
How many of you are done? Please put a dot.
Sir, 1 minute.
Sir, one doubt is there. Sir, you told that last formula is little incomplete. So why we are writing that?
1 minute.
अरे क्योंकि वो जनरल फॉर्मूला है ना डिस्प्लेसमेंट का.
ठीक है.
मतलब तूने सेकंड में भी जो तूने सी का वैल्यू लिया उसके बाद जो सॉल्व किया ना वो बस ऑसिलेशन वेलोसिटी ऑफ ऑसिलेशन का.
अच्छा ठीक है.
Okay. I could not hear. I went off. Tell me what was the dot?
Sir, he was asking that the last equation which we did, sir, that is not the final equation for
It is
oscillation.
not the final. It is not the final, but
so
it is
he
the
was
general form.
So he was asking why we are doing it. So I told that.
We are taking it as a general form for now.
Okay, sir. Thanks.
Okay. Now listen to this. Tell me as our summary. So what is the general formula for acceleration? Correct. What is the formula for velocity? What is my general formula for displacement? Correct. Now I would have given you this as direct formula. Now you know how did the formula come. Okay. Now my next question is, start. Try to get one formula for acceleration at mean position. Start.
Sir, done.
1 minute.
Sir, done.
Okay, listen. I will show it on the screen. You tell me whether you have understood or not. Okay. See here. We know that acceleration is equal to minus omega square x. We know this formula. And also, can I say
X is equal to 0. Yes.
So
Yes,
make
sir,
a note of this
understood.
derivation. Make a note of this derivation.
Okay, sir.
Okay, now listen. Acceleration is equal to 0. Therefore, now if I do the diagram of my simple pendulum, this is my mean position and this is my extreme position. Correct? Now I already know at mean position my displacement is minimum, which is 0. And at extreme position my displacement is maximum, which is plus or minus a. Now I also came to know at mean position my acceleration also is minimum, which is 0. Understood? Easy?
Yes.
Now my next derivation, try to do it. Start.
Yes, sir, dad.
Yes, you can say it will be maximum. That is correct. I got the answer from Nikhil. Very good. Okay, now let us start. Let us start. See here. To find acceleration at extreme position, I know the formula for acceleration as minus omega square x. Now, tell me, at extreme what will happen?
Sir, x will be equal to plus minus a.
At extreme, x will be equal to plus or minus a. Therefore, can I say acceleration will be minus omega square plus or minus a. Therefore, acceleration will be plus or minus a omega square, which will
Yes,
be
sir.
maximum. Therefore, make a note of this. Got the answer? Now, can I write it over here? See here. at mean position, acceleration is 0. Therefore, can I write at extreme position, acceleration is maximum, which is a omega square plus or minus, I'm ignoring, I'm just writing omega square. Do you see my table or summary coming up? Therefore, now I know displacement at mean, I know displacement at extreme. I know acceleration at mean, I know acceleration at extreme. Understood? Can I go to the next derivation?
So 1 minute.
Yes, sir.
Sir, done.
Sir, 1 minute.
Okay, now look at this. Next derivation. Start.
Sir, we don't know the value of velocity.
We don't know the value of velocity at mean, correct? Now there's a derivation. Start. Now you will know. Now you will know.
Sir, done.
Nikhil, check your answer. Okay, start. Okay, now to find velocity at mean, everyone look at the screen. Everyone look at the screen. We know the formula for velocity, general formula is what? Correct?
X is 0.
I anyway knew it was maximum at mean. I showed you that video last class. I anyway knew it was maximum. Now I even came to know the value that my maximum velocity is plus or minus a omega. Clear, clear, clear. Okay, make a note. Then I go back to that table.
So sorry, the
Someone-
message was by mistake. Sorry, sir.
No problem. Everything is fair in love. Today you have to visit your girlfriend's place again, right? In Oscillation. So,
Yes, sir.
yes. Today Shairi I will dedicate to Samarth's girlfriend.
Sir,
Okay, sir.
sir, with Shairi, okay?
Shairi I will tell you. Whenever you want, I'll tell you the Shairi at the end of the class. But whenever you want, we can tell the Shairi. Now, if you look at velocity, now if I write over here, we found velocity at mean position. Therefore, I can write velocity at mean position is maximum. Everyone look at the screen. And the value is A omega. Got it? Clear? Now, can you guess the next derivation? To find velocity at extreme.
Extreme.
Start. You anyway know the answer, correct? You anyway know the answer. Now you have to prove it. What is the answer?
So done.
Correct, Soumya. You're right. Displacement and acceleration go together, and velocity goes somewhere else. Okay, now to find velocity at extreme, look at the stream. I know okay. Got this answer? Therefore, velocity at extreme position is 0. Make a note. Make a note of this derivation. Velocity at extreme position is 0. Now make a note of this table. I'll be back in 1 minute. I'll get water and come. Make a note of this table as your summary. 6 formula on your screen. Okay, start. Okay, finished?
Yes, sir.
Now, listen to me. Everyone, concentrate before I ask you the Viva. Okay. How many formulae for acceleration now you know in this chapter? Start.
3.
General formula. Then acceleration at mean, can I say is minimum, which is equal to 0. And acceleration at extreme, it is maximum, it is A omega square. Can I say these three formula you know for acceleration in this chapter? Check, confirm and reply.
Yes.
Yes? Sure? Okay. Now tell me, how many formula for velocity you know in this chapter? One is a general formula, V is equal to correct?
Yes.
Velocity at mean is maximum, it is A omega. Can I say three formula for velocity in this chapter?
Sir, plus minus is not important.
Plus minus is not important. For me, for you it is, for me it is not. In the sense they just, it is right hand side, left hand side, right hand side, left hand side, correct? Doesn't matter. Displacement, how many formula you know? Tell me.
3.
So 9 formula you know, 3 formula for acceleration, 3 formula for velocity, and 3 formula for acceleration, correct?
Yes.
Therefore, I want you to go through 9. In addition to that, you have also correct. In addition to that, you also have that's it. So 9 plus 4, 13 plus 1, 14 formulae only. So we have studied only 14 formulae till now. Now you might be thinking, how many formula does oscillation have? We have already studied 14. It feels like I have studied all. Don't worry, we have only 32 formula in oscillation. Okay? So we have finished 14.
Sir, just 32.
32 only.
Yes, 32 only.
It's very simple.
We are in Mumbai, right? In Mumbai, putting only is nothing. 1 BHK at 3 crore only. Okay. So now you have to study this 14 formula only, and I'll ask you some of them. Are you ready? Ready right now or need time to revise?
Need time.
Especially this one. It's very, very important. This is the 3 formula for mean and 3 formula for extreme. Now, when I ask you what is velocity at extreme, you should not say velocity at extreme is 0. No. Velocity at extreme is minimum 0. What is displacement at extreme? Displacement at extreme is maximum plus or minus A, where A stands for amplitude. I want properly packaged answers. Okay, good.
Sir, the acceleration and extreme would be plus minus A omega square, right?
Yes. Plus or minus is like swadanusar. You can put it anywhere you want. Like it, put it. How much time you need?
2 minutes.
5 to 10 minutes.
5 to
Well,
10
sir.
minutes. Oh my god.
No, not much.
2 minutes. 5, 5, 5. I will start. 555. One minute. Okay, listen. Next topic is displacement of a particle starting from mean position. Just hear me out. Just hear me out. What is the difference between at mean and starting from mean? What is the difference between at mean and starting from mean?
Sir, at mean means
A
it.
particle is
Going from
resting
mean
at
to extreme, sir.
For example, if I tell you I am at home, and if I tell you I'm starting from home, okay? When I tell you I'm at home, that means after some time also I'll be at home only.
Yes.
But if I tell you I'm starting from home, that
Means
means after
that
some time I will not be at home. I will go
Yes.
outside home. Correct. So that is
Yes.
the difference between at mean and starting from mean.
Okay.
Now, can I say whenever anything is starting, t is equal to 0 because you're just starting? And can I say at mean x is also equal to 0? Therefore, what is my formula for displacement? Tell me, what is my general formula for displacement? X is equal to a sine omega t plus phi. Now, can I say, let me put these two values and get the value for phi? I told you my equation is not complete. I have to complete it now. Now I am completing. Now tell me, if I put t equal to 0 and x equal to 0, what will be my value for phi? Start. Did you understand why t equal to 0? Because anytime you're starting, your time will be equal to 0.
Correct, sir.
Start. Tell me what is the value for phi?
1 upon a sine.
Answer is, listen. Let us start. X is equal to 0 is equal to a sine omega into 0 plus phi. Therefore,
Yes.
0 by a is equal to sine phi. 0 equal to sine phi. Therefore, 0 means sine 0 equal to sine phi. Therefore, the value of phi is 0. Now, if I put the value of phi equal to 0 over here, I will get the answer of displacement as x is equal to a sine omega t. This is my answer for displacement of a particle starting from mean position. With that, now you have 4 formulae for displacement. Listen to me. General formula: displacement at mean, displacement at extreme, displacement of a particle starting from mean. Can we go to the next topic? Everyone got this? This is displacement of a particle starting from mean position. Now let me go to the next topic. Can you predict what will be the next topic?
Starting from extreme.
Start. Anyone got the answer? Now stop writing. Let me show you the answer, and after that you copy. Okay, now let me show you the answer, then you copy. Now I know that since it is starting T will anyway have to be equal to 0 because it is
Yes.
starting. Okay. Since it is starting, T will anyway have to be equal to 0. And since it is starting from extreme position, can I say X will be equal to plus or minus A? Now, what is the formula for displacement? Can anyone tell?
A
So A
sin
sin
omega t plus phi.
omega t plus phi.
Then T equal to 0, X is equal to plus or minus A. I will just take it as A. I'll ignore the sign. Is equal to A sine omega into 0 plus phi. Therefore, A and A will cancel. Therefore, 1 is equal to sine phi. Therefore, can I say 1 is equal to sine pi by 2 is equal to sine phi? Therefore, can I say phi is equal to pi by 2? Now put phi equal to pi by 2 in this equation. Stop writing. Listen, put phi equal to pi by 2 in this equation. Tell me what will be the answer.
A.
Can I say sine 90 plus theta is cos theta? Therefore, can I say displacement of a particle starting from extreme position is x is equal to a cos omega t. This completes our next derivation. Therefore, what is the formula for displacement? Now you know 5 formula for displacement. First copy this, then we'll do a revision. Okay, start copy it.
Sir, how did it happen? Sin to cos. Okay, okay, understood.
Sir, negative cos will come now.
Why? Why negative cos will come?
Sir, you did it by the second quadrant wala logic.
Plus or minus all anusar I told you. Sine 90 plus theta is cos theta.
Yes.
You're talking with this logic, all silver teacups. That logic you're talking about.
Yes.
Done? Now look at the screen. Now listen. How many formula for displacement you know? Look at the screen. Can I say one is a general formula? What is a general formula? X is equal to a sine omega t plus phi. What is the next formula? Displacement at mean position is minimum, which is 0. What is the next formula? Displacement at extreme position is maximum, which is plus or minus a. Now, next, tell me which is the next formula.
Sir, displacement starting from mean is
Displacement starting from mean.
A sin.
And displacement starting from extreme.
Extreme. A cos WT.
So these are the 5 formulae for displacement that we have studied today.
Yes, sir.
Now can I start my viva? Now it will be sweet 16 for me.
Yes, sir.
Sir, only 16.
Only 16.
Yes, sir. Done.
Okay, now everyone switch on your cam. Let us start with the viva. Okay, start. We'll start with Soumya.
Yes, sir.
Soumya, tell me what is displacement, velocity, and acceleration at mean position?
Displacement is minimum, which is 0. Velocity is maximum, which is plus minus e omega. And acceleration is also minimum, which is 0.
Very good, Soumya. Samarth.
Yes, sir.
What is displacement, velocity, and acceleration at extreme position?
Sir, at extreme position, the displacement is positive negative amplitude, which is maximum. Sir, velocity is 0, which is minimum. And acceleration is positive negative omega square.
Positive, negative, omega square.
Square A. Omega square A.
See, people switching off their cam very happily. Can you see the screen? Very few people switching on. I want all cam on. Tighter.
Yes, sir.
Tell me, what is the formula for maximum velocity and where does it happen?
Formula for maximum velocity. It happens at the mean position. Okay, the formula. Formula for velocity at the mean is v equals plus minus a omega.
Correct. Nikhil. Nikhil, tell me what is the general formula for acceleration, for oscillation?
Yes, sir. For ये acceleration का general formula for oscillation is minus omega square x.
Okay, Lavnish.
Yes, sir.
Tell me what is the general formula for velocity of oscillation?
Yes, sir. It is plus minus omega a square minus x square.
Where is the root?
Sorry.
Which root? Joe root.
No, sir.
Square root. Square root, yes. Correct. Krish Shetty.
Yes, sir.
Krish Shetty. Correct? Yes. Tell me any 5 formulae for displacement of oscillation.
Displacement of oscillation. First is
First is Vandu. Second is Eradu. Third is Muru. Tell me.
a sine wt plus phi.
No W
Omega t.
in this
Omega
chapter.
t.
Omega, yes. Omega T.
Omega t
Okay.
plus phi. And
Okay.
at mean it is minimum, which is 0.
Hmm.
At extreme it is a cos omega.
No. That is formula Aru. You know what is Aru? Krish?
Sir, can you repeat?
You know what is Aru?
No.
Aru means 6. You gave me 6 formula, which is not there.
Then
If I ask Saish, she will give me all 5 answers right now. But I'm not asking Saish right now. I'll ask him in some time. Okay, Saish? Yes. Krish. Barpundu Barpuji.
don't remember.
Gottilla. Gottundu.
Gottiji.
Gottilla. Wow. What confidence? Why?
Sir, I can't remember all 5.
You can't remember all 5. How many can you remember?
A sine omega t plus phi, and at mean it is 0. At extremes it is plus minus a, which is maximum, and sir, I only remember these many.
Okay, fine. Saish.
Yes, sir. Yes, sir.
Saish, tell me, what is the formula for maximum acceleration and where does it occur?
Maximum
Acceleration.
maximum acceleration is plus minus a omega the whole a omega square
And where does it occur?
at the extreme position.
Priyanshu.
Yes, sir.
Priyanshu, tell me what is the general formula for displacement?
Sir, a sine omega t plus phi.
A sin omega t plus phi. Okay. Jigar Gada.
Yes, sir.
Jigar. I like one thing about Jigar.
Hello.
You know what is one thing I like about Jigar? Jigar, tell me what is one thing I like about it.
Sir, I don't know.
You look excellent. You look majestic. That is one thing. Second. Today's class we will give one Shairi for Samarth. Next class I'll give one Shairi for Jigar. Okay.
Sir, you give now.
Actually, Sulochna ma'am had already put one Shairi which I can dedicate to you. That we'll see.
Sir, you can give now.
I like Jigar's one message. If the class is at 1 o'clock at 12:59, there is a message, link and question mark. That is one message of Jigar I like the most. Just 1 minute before the class starts, link and question mark. This is very nice. I like it, Jigar. So now, Jigar, tell me, any 5 formulas for displacement? Can you try?
Displacement. Displacement A sine into WT plus that sine into the circle.
That's another.
I don't remember that thing.
It's fine. It's fine.
Then it's general formula on then it's sir, I don't remember all. Sir, it is 0 at B position. That outward direction.
Jainam, can you try all 5 formula?
Yes, sir. So, x is equal to a sine bracket wt plus pi tan at mean a is equal to 0.
X equal to 0. Huh?
At extreme a is equal to plus minus a. Tan
Stop. At mean x is equal to 0. At extreme x is equal to plus or minus a. Okay, and then
starting from mean x is equal to a sine wt. Starting from extreme x is equal to a cos wt.
Omega. There is no w. That is omega.
Yes.
Pratham.
Yes.
Pratham, tell me, what is the formula for restoring force and what is the formula for force constant?
What, sir?
What is the formula? What is the formula for restoring force and what is the formula for force constant?
Sir, I don't know this. I don't remember.
Why you don't remember? We did it in today's class also.
Yes, sir.
Sir, can you repeat the question?
You're absent for the last class, Pratham?
Yes.
Oh, why? Have you seen the recording of the last class?
No, sir.
Why?
Oh, sir, I forgot.
Sir, what did you ask? Can you repeat the question?
Yes, title. I read that. Tell me some. Who was saying something?
I was asking, can you repeat the question?
For which? For you or for him that I said right
Or for him that you said?
For him, okay.
But I remember
the question I asked him was, you are also absent in last class, Jigar?
Yes, sir.
Yes. So the question I asked him is, what is the formula for restoring force and what is the formula for force constant? Pratham.
Yes.
Tell me, want to give JEE? Want to give JEE, Pratham? Not sure. Pratham is thinking now. What is JEE? Pratham, are you there?
Yes, sir, I got disconnected.
Yeah, Pratham. My question is, do you want to give JEE?
Yes.
Very much or okay? Okay.
What, sir?
You want to give very much or you want to give okay, okay? Are you interested in it so much? Or?
Very much.
Very much. Very much.
Yes.
So preparation also should be very much correct, Pratham?
Yes, sir.
Then are you waiting for what? Are you waiting for IPL to get over?
No, I don't watch IPL.
Then are you waiting for any season to get over to start studying? What are you waiting for? What is the Shubh Muhurat you're waiting for?
Sir, I was preparing for the test and all that.
Which test? Blood test?
No, this upcoming test on Sunday. That's why.
Achha. That's why. Okay, so you'll prepare only for the test, nothing else.
No, I'm not getting time because of that.
Achha, not getting time. Okay. Okay, fine. I have Aryan who has kept camera off. So Aryan, I think I'll have to put you in waiting room. Oh, I got Aryan. Yes, I got Aryan. We have got Aryan on camera. Aryan, can you show your face? Yes, now I can see Aryan. Very good. Okay. So Aryan, tell me, what are the two formulae for omega? What are the two formulae for omega?
Two formula for omega. Omega square is equal to k upon m and 2 pi upon m.
And 2 pi upon?
M.
2 pi upon m.
Sir, it is
Something
correct. I'm
no,
not
it is not
confirmed.
correct. First formula, at least I can give it to you. Second formula, I cannot give it to you. Subra Samir.
Yes, sir.
Yes, Subra. Why keep your camera off?
To washroom, so then I didn't keep it on.
So, Subra Samir, now tell me. What is the formula for maximum velocity and what is the formula for maximum acceleration?
Formula for maximum velocity is W equal to plus and minus equal to plus and minus AW omega.
No, I'm not happy with the answers. Not happy with the answers. Most of you know. I'll come to others. Before that, let me start with the new concept. And this is the last topic for today. This is the last topic for today. And the topic is, listen to this. First, I will find the value of kinetic energy. Then I'll find the value for potential energy. And then I'll find the value for total energy. Is it fine? Tell me yes or no. Okay. Then I will find total energy at mean. Then I will find total energy at extreme. These are the 5 things I need to do. Okay. So the side heading that you need to write is energy of oscillation. Right up. Side heading, energy of oscillation. Okay. Now listen to this. I need to get an expression for kinetic energy of oscillation. Now for that, listen to this. find kinetic energy of oscillation. Now listen to this. Kinetic energy, as you know, is half mv square. Easy. You know, kinetic energy is half mv square. Now, can I write kinetic energy is half m? Instead of v square, I can write yes. Okay. Open the bracket. What will I get?
Half omega square a square minus x square.
Correct. Now, what is m omega squared? Can anyone tell me what is m omega squared?
Sir, K.
This is the derivation for kinetic energy of oscillation. Therefore, if I ask you what is the general formula for kinetic energy, you will tell me it is half mv squared. That we anyway know. But if I ask you what is the formula for kinetic energy of oscillation, you will tell me half k a square minus x square. Make a note of this formula. Kinetic energy is equal to half k a square minus x square. This is your new formula also. Kinetic energy is half k a square minus x square. Make a note. What the answer for kinetic energy? The answer for kinetic energy, if I ask you what is the kinetic energy of oscillation, you will tell me it is half k a square minus x square, correct? Now, everyone done with this derivation?
Yes, sir.
Over. Derivation is over. You directly have the formula for potential energy of oscillation. That is half k x square. Make a note. Therefore, what is kinetic energy of oscillation? Half k a square minus x square. And what is the formula for potential energy of oscillation? Half k x square, correct? The formula for kinetic energy of oscillation is half k a square minus x square. And the formula for potential energy is half k x square. Made a note already, all of you?
Yes, sir. Sir, half k a square, right?
Look at this. Can I say total energy is nothing but kinetic energy plus potential energy? Total energy is nothing but kinetic energy plus potential energy. Therefore, total energy is nothing but what is kinetic energy? Can anyone tell me? Half k
Half k a square minus
a
x
square
square.
minus x square plus potential energy half
K x square.
Correct? Therefore, can I write total energy equal to half k a square minus x square plus x square. Correct? Because half k is common. Therefore, can I say minus x square and plus x square cancels? Therefore, can I say total energy of oscillation is half Ka square? Make a note. Total energy of oscillation is half Ka square. Got it? Got it? Therefore,
Yes.
now in your mind, think about it. What is the general formula for kinetic energy of oscillation? Half Ka square minus x square. What is the formula for potential energy of oscillation? Half K x square. And what is the formula for total energy of oscillation? Half K A square. Now, look at my next topic. Last two topics, then we are done, okay? So listen to this. Total energy at mean position. Okay. Now, please look at the derivation first and then tell me whether you understood or not. Now, tell me, what is my formula for total energy? My formula for total energy is kinetic energy plus potential energy, correct? Normal. Or can I say my formula for total energy is kinetic energy is half K A square minus x square plus half K x square, correct? Now, can I say at mean x is equal to 0? Can I say at mean x is equal to 0? Therefore, can I say total energy is equal to half K A square?
Yes, sir.
Therefore, what is the formula for total energy? Tell me. Half K A square, correct? Now tell me what became 0. Can anyone tell me what became 0? See here. What became 0? This term became 0. What was this term? Potential energy. Therefore, can I say at mean
Potential energy is
my potential energy will be equal to 0?
Yes.
Therefore, my complete total energy will be equal to kinetic energy. Did you understand my conclusion?
Yes, sir.
And did you
Because
notice that my
potential
final answer? Can you say my final answer did not change? Total energy, that is law of conservation of energy.
Yes.
Energy can neither be created nor destroyed, it will remain the same. Half K A square. Did you understand this derivation?
Yes, sir.
At extreme, vice versa will happen. Kinetic will become 0, right?
Yes, that I'll do next. First, make a note of this. Very, very important conclusion. Got it?
Yes, sir.
Now,
So 1 minute. Yes, sir. Done.
Sir, can you show the
total.
previous slide for a second? Okay, sir, done.
Now, can I say total energy? Please look at the screen. Can I say total energy is kinetic energy plus potential energy, same starting? Or can I say total energy is half K A square minus x square plus half K x square, correct? Now, at extreme, x is equal to plus or minus a. at extreme x is equal to plus or minus a. Therefore, can I write total energy is equal to correct? Therefore, can I say total energy is equal to, answer did not change, but what became zero? Check what became zero. This thing became zero. What is this thing? Kinetic energy. Therefore, can I say at extreme position, my kinetic energy will become zero. Therefore, my total energy will be completely equal to potential energy. Make a note. Therefore, my total energy will be equal to potential energy. Got it? Can I turn the page? Can we do a conclusion now?
Yes, sir.
Yes, sir.
Listen to the conclusion. See, when I did my total energy, does my total or did my total energy have x in it? Displacement? No, correct?
No.
Did my total energy have displacement in it? No. Therefore, whether it is mean, that means whether x is equal to 0 or whether x is equal to plus or minus a, it will not make any difference to total energy. You should have told me that my total energy does not depend on displacement at all. Anyway, correct? What is total energy? Half k a square. Therefore, if x is equal to 0 or if x is equal to plus or minus a, what difference does it make? Nothing. Therefore, my final answer will remain the same. But what we came to know is that at mean position, potential energy is 0. Therefore, my total energy is kinetic energy. And at extreme position, my kinetic energy is 0. Therefore, my total energy equal to potential energy. Therefore, now which are the 5 formulae that you have? First one is kinetic energy of oscillation. What is the formula for kinetic energy of oscillation? Half k a square minus x square. What is the formula for potential energy of oscillation? Half k x square. What is the formula for total energy of oscillation? Half k a square. What is the formula for total energy at mean? Total energy at mean is also half k a square. What is total energy at extreme?
Half k square.
This is your summary. Make a note. Got it?
Yes.
This completes our 60% of oscillations for JW also. So when we do it from the module, we can easily do the questions, but I will first complete the other part and then we go to the module directly. So we can directly jump to the questions of the module. Okay, please revise and please make sure you know all this because today we did 14, 16, 17, 18, 19, 20, 21 formula already. By now, we have done 21 formulae already. Okay, Nikhil, WhatsApp me. Okay, with that, I think we can stop for today. In today's class, do you have any doubt? In today's class?
Sir, Shairi.
Yes, Shairi, I will tell you. Shairi, I will tell you. In this oscillations, do you have any doubt for today?
No, sir.
Okay, no, that is fine. Then